This is concept 2, projectile motion, and this is number 2. And the problem says, a student throws his worthless lab partner off a 240-meter high bridge with an initial downward speed of 8 meters per second. How long does deadbeat have before he hits the ground, and what will his speed be upon impact? So initially we know that our change in x is 240 meters, which is how high the bridge is. And we know that the person is initially falling downward at a speed of 8 meters per second. So since he's moving downward, the velocity is negative. And we're trying to solve for the time and for the final velocity. So what I did first was that I solved for the final velocity of the kid. And I used the equation bf squared equals vi squared plus 2a change in x. And I use this because we have pretty much everything that we need already, so we can easily solve for it, because we have an initial velocity of 8 meters per second, square that, plus 2 times our acceleration, which is going to be negative 9.8 meters per second because the person is falling downward vertically, and our change in x, which is 240 meters. And we use this equation because we know this is basically for a vertical velocity and the person is falling downward vertically, and these are all the vertical components. So when you solve this out, it turns out to be 69.74 meters per second. There you go. And now that we have that, we can solve for the time at which the person will hit the ground, and we can use VF equals AT plus VI T, because we already have their final velocity of 69.74 meters per second, which is going to equal our same acceleration of negative 9.8 meters per second, times our T, which we don't know, plus, excuse me, one sec, this is not in the formula, ignore it, plus our negative 8 meters per second. And when you solve this out, time turns out to be 7.7 seconds.